We are in the week 3 problem solving session of the NPTEL course Network Analysis, and week 3 is about solution to linear differential equation with different excitation. Let me share my screen. Okay, so do you want me to quickly summarize what Sir has taught, or do you want to directly jump into problem solving session? Whichever way you are
Sir, please
comfortable
give
with,
us
we
summary,
can
sir.
do.
Sir,
Sorry.
please give some summary first, then
Okay.
answer
Okay.
this.
Okay. Then based on, I'll ask you a few questions, and based on whatever you have understood, from there we can continue. So yeah, let us consider one first order differential equation dy by dt plus ay is equals to x of t. So let me go to my writing pen. So week 3 is about linear differential equation, solution to linear differential equation. So we have, you are able to see my screen, right? Whatever I'm writing.
Yes,
Okay.
sir.
Okay. Okay. So first we'll start with first order. So because it is the simplest one, and whatever Sar has taught from first order, second order to nth order. So if we directly dive into nth order, it would be somewhat difficult for us to understand the concept. So we'll slowly increase from first order, and then we'll have a generalized solution so that we can solve any problem with nth order differential equation. So first we'll be doing first order differential equation. So I'm writing first order. So we have one expression, so dx of t by dt plus, we'll just take the similar example, or dy by dt. Okay. So dy by dt plus ay is equals to x of t. So you tell me how to solve this kind of expression. So how to start with this kind of problems.
Sir, first write the character equation.
Okay.
M plus a equal to 0, so m equal to minus a. Then we write the solution e to the y of t equal to e to the power minus at
Okay.
plus plus k1 into x प्लस और कुछ नहीं होगा सर, x t 0 उसके बाद 0 हो जाएगा.
Okay, so
1 है.
yeah, you are almost correct. We'll get there. So when we say x, k naught x plus k1 x dash, we do not know about x because we do not know the order of x. So we'll write an infinite series. Okay, before going to that part, before generalizing, we'll solve in the way we were taught in our first years. So usually if we have this problem and if we do not know the solution, right, we'll multiply by e to the power at, right?
Yes, sir. Yes, sir.
Yes. So I'll write the same thing. dy by dt plus ay is equals to x of t. Now I'm multiplying with e to the power at, e to the power at, here also e to the power at, here also e to the power at. Now after doing this, I'll get e to the power at dy plus ay e to the power at dt is equals to x of t e to the power at dt. Do you agree? Hello.
Sir, why dt is multiplied
So I have multiplied the
with
dt
ay?
also. So I'll tell you why I have done. Hello.
Yes, sir. Yes, sir.
Okay. So now if you consider this LHS side, the LHS side I can write d of e to the power at into y, right? Because d of xy is there, we'll get x dy plus y dx. So
Yes, sir.
so we got this expression. So for that purpose, I have multiplied by dt, and my RHS side is x of t e to the power at into dt. So let us integrate on the both sides. So we'll use a, say from integrating from 0 to t, and the initial condition say y of 0 at t equals to 0, say y is y equals to 0, and here it will be y of t. So now after integrating it, what will I get? I will get e to the power at into y of t minus y of 0, because e to the power 0, t is equals to 0. So e to the power a into 0 is 1, is equals to integral, sorry, is equals to integral 0 to t x of t e to the power at dt. So y of 0 is unknown. So for the time being, we are assuming this to be a. So now we will get y of t is equals to a into e to the power minus at plus e to the power minus at into integral 0 to t x of t e to the power at dt. Do you agree? I have
Yes, sir.
taken the a on the RHS side and multiplied with e to the power minus 8 on both sides. So now here I can see two things. One is this one and one is this one. So if I put x of t is equals to 0, say there is no input, then my y of t is equals to a into e to the power minus 80, right? Because here I can see x of t is there. So this term is caused by the input. This is coming from the input, and this is not related to input. So in such scenario, say if the x of t is not there, my y of t is simply a into e to the power minus 8. So this y of t term is called is coming because of the natural response. So this is the natural response, and x because of x of t is coming, it is dependent on the input, and that's why we call this forced response. So who is responsible for forced response? My x of t, my
Input.
input. But who is responsible for natural response? If there is no input, who decides like the natural response? It is dependent upon the initial
The
condition.
yes, sir.
Yes. So because here we have considered y of 0 to be some finite value, right? So this, say this is some finite value, which means at the beginning of the at t equals to 0, my system is output is not 0, so it has some initial condition. So in such cases, when the input is 0 and we want to see the natural response, then it happens only when there is initial condition. So the natural response is driven by the initial condition. Okay, and this is driven by the input. So for every y of t, we'll have one natural response yn of t plus, hello, can you hear me?
Yes, sir.
Okay, okay. Plus some forced response yf of t. So for any given equation, I can first solve for either yn of t or solve for yf of t. Now let me consider yf of t. So I'll consider, okay, a new page. So now I am considering yf of t from my previous equation. So yf of t is what? E to the power minus 80 into integral 0 to t x of t e to the power 80. So my yf of t is equals to e to the power minus 80 integral 0 to t x of t e to the power 80 dt. So it has again two functions, right? X of t and e to the power 80. So now what needs to be done? We can write this as we know that formula, right? E to the power 80 into, first it will be x of t and then integral e to the power 80 dt minus integral x dash t into integral e to the power 80 dt, right? I have used that formula, integral u v dt. So it will be u into integral v dt minus u dash into integral v dt. Is this part clear?
Yes, sir.
Okay. So now, if you, I'm not getting into like solving this thing, but if you keep on solving this, what you will be getting? You will be getting some polynomial of x of t. I'll not go into that because we have so much to discuss today. So it will be like a polynomial of x of t. You can solve it. I think sir might have solved. If you check, it will be like k naught into x of t plus k1 into x dash t plus k2 into x double dash t plus up to solve. So my y forced response is dependent upon x of t, and it will be like a polynomial of derivatives of x of t as well as x of t, and it will be infinite. So how many terms will be there? It will be n number of terms such that the nth term, the nth derivative of the x becomes 0. So this is my yf of t. Now coming back to my natural response, yn of t is some constant a into e to the power minus 8. So now, if we go back to the question, what we had dy by dt plus ay is equals to x of t. So now, I'll directly write the solution. The solution is y of t is equals to two parts. One is a into e to the power minus 80, and the other part is a naught x of t
A zero x
plus k1. Sorry.
a plus k1 x dot t
Yes.
plus k2 x double dot t
Yes,
plus so
yes,
on.
yes, and so on, and n number of terms depending upon the order of the x of t. So we have one natural response and one forced response. So this can be directly written by following certain rules and guidelines. So what we do is first we'll solve for natural response and then we'll solve for forced response. So first, how to get yn of t and how to get yf of t. So for getting yn of t, which means it is because of the natural response of the system and there is no input. So what I'll do is I'll do x of t is equals to 0. So I'll insert x of t is equals to 0 to get my yn of t. So for that, I'll get dy by dt plus ay is equals to 0. Now I'll consider an operator. So my operator is d. So d is my differential operator. So I am considering capital D as d by dt. So now what will be my equation? My equation will be dy plus ay is equals to 0. So it is an operator. Understood? Are you able to understand until this point?
Yeah, please repeat one second.
So for calculating the natural response of this output y of t, I know that natural response only happens when my input is 0, because if I put x of t is equals to 0, then all these terms will be 0. So my y of t is my natural response yn of t. So to do this, I'm considering x of t is equals to 0. So this is natural response. After putting x of t as 0, I have considered an operator is d by dt. So d is equal to d by dt. So if I say dy, it is nothing but dy by dt. So from here, I am getting this expression. So even though it is an operator, we'll consider it as some variable because that is according to the rule. So now I can write this as d plus a into y equals to 0. So what are the solution? Assuming say d is some random variable, we'll get d is equals to minus a, right?
Yes, sir.
Yes. So in such scenario, say if first we have to put the operator and then get the solution. Say if the solution is x1, then it is said that our solution will be some constant a into e to the power minus 80, because this minus a is coming from this. Okay, so in order to make you understand better, I'll consider another example. Say I have d plus a1 into d plus a2 into y is equals to 0. Then what will happen? Then we'll have D is equals to minus A1 comma minus A2, right? So then my natural response yn of t will be some a into e to the power minus a1 t, this is also minus, plus b into e to the power minus a2. So what are the solutions or the roots of that polynomial? From the polynomial, we'll write an exponential solution. So that will give us my natural response. Is that clear?
Yes, sir.
Okay.
Yes, sir.
Okay. So this gave me my natural response. So here I'm keeping my natural response. Now, if I come back to forced response is quite simple. If the function is x of t, then it will be k naught x of t, k1 x dash t plus k2 x double dash t, etc. Sir, can you please explain second step again before integral in the first page? Okay. Let me go back to first page. So if you are asking about this step or maybe this step, let me quickly explain. So the given function or the equation is like this: first order differential equation. I have multiplied by e to the power at. Why? Because I want it to be in this format. So that's why I have multiplied by e to the power at. After multiplying by e to the power at, I have multiplied on both sides by dt. So my term will be e to the power at dy plus ay e to the power at dt. Now this LHS, I can write this as d of e to the power at into 1. So if you have some queries regarding this, so d of uv is nothing but u dv plus v du. Okay. Now d of e to the power at y is nothing but y into d of e to the power at plus e to the power at into dy. Now I know that differentiation of e to the power at is nothing but a into e to the power at. So it will be a y e to the power at into dt plus e to the power at into dy, which is this thing. So I have directly written it like this, and my RHS I have kept it like that. Then I have started integrating from 0 to t, and then I have kept on solving. Hope this made it clear. Okay. So now we got how to calculate the natural response and how to calculate the forced response. So let me just write. So if my equation is dy by dt plus ay is equals to x of t, I got y of t is equals to a into e to the power minus at plus k naught x of t plus k1 x double dash t plus up to some infinite terms until the derivative of the x of t becomes 0. Okay. So now let us quickly solve one example. So this is also written the same thing. So it has a natural response and then forced response, and after integrating by parts you will get a function of x and derivative of x, and then the total solution will be like this. Okay, so let me quickly consider one problem that they have given. So let us consider this problem: dy by dt plus 3y is equals to t, and boundary condition is y of 0 equals to 1. So let me consider a quick problem. So problem 1: dy by dt plus 3y is equals to t, semicolon, y of 0 is equals to 1. Right, dy by dt plus 3y equals to t and y of 0 is equals to 1. So here, so if I start with the natural response, so what will be my natural response expression? Anyone?
So y and t equal to e to the power minus 3t.
Yes. So my natural response is yn of t is equals to some constant a or b, whatever, a into e to the power minus 3t. So this is my natural response. Now what will be my forced response?
Sir, first mode
Yeah,
take y equal to t.
Sir, K1T
Sir,
plus
taking
K2.
k1t plus k2. Yeah, you are right. So my forced response will be y f of t is k naught into x of t. So k naught into t plus k1 into x dash of t. X dash of t is 1 plus k2 into x double dash of t, which is 0. So it will be k naught t plus k1. So my total solution is what? Total solution y of t is equals to yn of t a into e to the power minus 3t plus k naught t plus k1. Now I have three unknowns. So how do I solve this? One thing we need to keep in mind is this individually and this individually satisfies the given differential equation. So this satisfies the given differential equation. So what I mean to say is if you put y of t is equals to a into e to the power minus 3t in the given equation, then LHS should match with the RHS. Similarly, if you put only the forced response in the given differential equation, then it should also satisfy the given differential equation. So if you have any doubt, we'll just check whether it is matching or not. So I'll consider y of t is equals to, I'll do this here. So using this color. So y of t is equals to a into e to the power minus 3t. Okay. So my dy by dt is what? Dy by dt is equals to a into minus 3 into e to the power minus 3t plus e to the power minus 3t into 0, right? Or what? What will be my expression? Hello. So if I differentiate this with dt, what will be my expression?
Sir.
This one only, right? Hello. I'm differentiating this.
Yes, sir.
Yes. So dy by dt will be what? Minus 3a into e to the power minus 3t. So now
Minus 2 into.
dy by
Yes, sir.
dt plus 3y is nothing but minus 3a into e to the power minus 3t plus 3a into e to the power minus 3t, which is equals to 0. Because we are checking the natural response, and natural response means input is 0. So on the RHS side, we'll put 0, and we have seen that it is satisfying because this is natural response. Now, if you put forced response, which means for the given input, whatever solution you got, it should satisfy the given differential equation. So we have, so now we are checking the forced response. If you have any doubt, please feel free to ask, because whatever we will be discussing today, they are just incremental concepts. So if you face any difficulty in this concept, you will not be able to understand the concept that we'll discuss in the next moment. So if you have any doubt, you please ask so we can spend more time. Then we can quickly go into the higher order differential equation. So for forced response, I am considering y of t is equals to k naught t plus k1, the generalized solution. And the given equation, they have given dy by dt plus 3t is equals to 1 or t. They have given. So I'll substitute this. Now can you tell me what will be the equation? Or if you can solve with me. So I hope you have a pen and paper with you. Just solve with me. So if I substitute y of t in this equation, can you quickly tell me what will be my expression?
dy by dt plus
So
dy
what will be
equal
dy
to
by
t.
dt? Substitute this in this equation.
Hmm.
Yeah, please
Sir,
keep
K
a pen
naught
and
plus
paper with
3t
me.
is equal to t.
K naught.
K naught plus, sorry, this is
3t.
actually 3y. I have made a mistake. The given equation is dy by dt plus 3y equal to t. Now, so now tell me k naught plus,
K naught plus 3 whole into K naught t plus K1
okay,
equal to t.
equal to t. So now, whatever solution we have got, it should satisfy. So I'll segregate 3 k naught t and then k naught plus 3 k1 is equals to t plus 0. Now I will check for the coefficient. 3 cannot. Here it is 1. Here it is this one. And here it is this one. So I will get two equations. One equation is 3 cannot is equals to 1. And k naught plus 3k1 is equals to 0. Now can you tell me what is k naught, what is k1? I have two equations, two unknowns. Can you quickly solve and tell me what is K0, what is K1? Okay, first of all, what is K0?
Sir, K0 1 by 3.
Okay, and K1? 1 by 3 and 3.33. No, I think K1 is wrong. K0 is correct. K0 is 1 by 3, okay, and K1?
K1 minus 1 by 9.
Minus 1 by 9, yeah, you are right. So now I got K1, K2, but still there is one unknown left in my solution. What is that?
A.
A. So now I'll write my y of t. My y of t is a into e to the power minus 3t plus k naught t. So t by 3 plus k1 minus 1 by 9. So how will I find a? So I'll quickly go back to the question.
You're putting the boundary condition.
Yes. So for the boundary condition, using that boundary condition, we'll get a. So can you quickly tell me if
Y
I
not
put
equal to 1.
y of 0 is equals to 1. So now can you quickly tell me what will be the value of a? Put t y equals to 0 on both sides and see what is the value of. So you substitute this here and then you tell me what is a.
10 by 9.
10 by 9. Is everyone getting the same answer? Is it? All of you are getting the same answer?
Yes, sir, yes.
Okay. So now what will be my final y of t? My final y of t is equals to 10 by 9 e to the power minus 3t plus t by 3 minus 1 by 9. So for the given differential equation, this is my solution. And out of that, this is my y natural response and this is my forced response. So I'll just check whether my answer is matching or not. I'll go back here and see. So my y of t is 10 by 9 e to the power minus 3t plus t by 3 minus 1 by 9. So it is exactly matching with whatever we should be getting and it is fine. So I'll do control S. I'll quickly explain how we have done. So initially, a linear differential equation, first order differential equation to be precise, has been given and a boundary condition has been given. And we'll, in any problem, we'll proceed with this like format. First, we'll solve for the natural response, then we can solve for the forced response. So from this, we know that d is equals to minus 3. So natural response is yn of t equal to some constant a into e to the power minus 3t. And for the forced response, it will be k naught into x of t plus k1 into x dash t plus up to so on. But other terms will become 0. So we have y of t is equals to k naught t plus k1. Now my entire solution is this plus this. But I know that forced response should satisfy the given equation. So if I substitute this k naught t plus k1 in this given equation, it should satisfy. So after putting that, I got two equations, two unknowns. Solving those gave me k naught and k1, but still a is unknown. So in order to solve that, I have again gone back to question. They have given a boundary condition. So using that boundary condition, I got the value of a. So now my y of t is this entire thing. Is this part clear? It's clear, right? If you have any doubts, you may ask. You got it? Okay. So, but whatever we have said, like natural response, you find the equations and then forced response derivatives. This is okay, but there is an exception case. So when we cannot apply this, we cannot apply this in a case where we have dy by dt plus ay, and my x of t is some constant a into e to the power minus at. So in this case, I cannot apply directly. I cannot say that natural response is e to the power some constant k into e to the power minus at, and my forced response will be derivative of derivative of these expressions. So why? We'll find out. So we'll again use our classical approach of multiplying by e to the power at on the both sides, and we'll see. So we'll first multiply by e to the power at. Here also e to the power at on both sides, and we'll see how we are getting the expression. So we'll get e to the power at dy plus ay e to the power at dt is equals to a dt. Do you agree?
Okay.
Yes. Right. Now this can be written as d of y into e to the power at, and this is a dt. Now I integrate it from 0 to t. Here also 0 to t. My LHS will be y of t into e to the power at
Well,
minus some constants ab is equals to, on the LHS side it will be at, right?
okay.
So now if you
Yes.
solve for y of t, say I'll add plus b on this side and plus b on this side. So this will get cancelled. And now I'll multiply by e to the power minus 80, and here also e to the power minus 80. So now I got the final answer as y of t is equals to 80 plus b into e to the power minus 80. So whatever we have previously done, that is not this one, because we got an extra term 80. So this needs to be remembered. So in a first order linear differential equation, if we have this kind of input or excitation, then whatever rule that or whatever procedure we have followed previously will not work, and that's why this is an exception case, and we need to be careful with this, because you will not get the actual answer. So we have gone with our classical approach, where we multiply by e to the power at on both sides and apply integration and then simplify it. So in that simplification process, we got y of t is equals to at plus b into e to the power minus at. So now again we'll substitute this back here. If such question exists, we'll substitute this back here, or we'll uh, get the b value. So let me, sorry, someone is saying something. Okay. So let me take a quick problem 2. So I have given dy by dt plus 5t is equals to 2 into e to the power minus 5t. So it is similar to, and say I have also given y of 0 is equals to 3. So it is similar to dy by dt plus, again, small mistake. This is not t, this is y. Okay, so this is similar to ay is equals to a into e to the power minus 80, right? So now what will be the solution? Using this by y of t.
F
Hello?
equal to.
Yes. Y of t equal
Yes,
to
sir.
So 2t plus b whole into e to the power
Okay, plus
minus 5t.
5t. So now how will I get b?
Boundary condition, sir.
Boundary condition, yes. So if I put boundary condition, what will be my value? What will be the value of b?
B, sir.
3. So now I got my final y of t as 2t plus 3 into e to the power minus 5t. If you want, you can also check by inserting this y of t in the given equation and see whether whatever we got is correct or wrong. One more thing, this cross-checking thing we can only do when the function is small. Say y of t is having 3-4 terms, then checking back is difficult. So whatever way or whatever calculations we make, we should be very careful with the mistake. So we should not do any mistake, else our entire answer will be wrong. So we should be careful with our calculation. And in the cases like y of t is only one or two expressions, then you can put back in the differential equation and see whether LHS is becoming RHS or not. So that part you can do later, but I think this will match because this is a simple mathematical calculation question. So there are like no chance of making errors. But in the exam, there might be some big question where a lot of equations will come and you need to be very careful with each and every step. Okay, so yeah, is someone saying something? Okay, I cannot hear you. If you are trying to say something, kindly mention in the chat box. So before we go into the second order uh, equation, do you have any queries till this point? No? Okay. Then we'll move on to the second order. If you have any questions and if your mic is having some issue or something, you can mention in the chat box. I'll address your queries. And there is less than a minute, so this meeting will end. Kindly join back. We'll continue our discussion. So now we have second order differential equation. Okay. So I think this meeting will end soon. You quickly join back. We'll continue our discussion. So second order is something like t square y by dt square plus a into dy by dt plus by is equals to x of t. So how to solve this type of questions? Okay. Are you able to see my screen?
Yes, sir.
Yes, sir.
Yes. So in such scenario, what we'll be doing is we'll do the same thing that we have done for the first order equation. We'll consider an operator, and this is a differential operator, so it is nothing but d by dt. So if d is equal to d by dt, d square will be d square by dt square. So this is just some an operator. This is some operator which we are using to simplify our understanding so that we can relate to it more easily. So if I substitute this operator there, then we'll get this expression. We'll get d square y plus a dy plus by is equals to x of t. So if I consider y to be common, we'll get d square plus ad plus b into y is equals to x of t. So again, I got some equation. Now I'll do what is the first part I'll be doing and what is the second part. So first I'll assume that two cases are we are considering. First case is the roots are identical, or maybe the second case because it's a special case. So the roots are different, and the second case roots are identical or roots are equal. So this is my first case, this is my second case. So first case, we'll assume that say the roots are m1 and m2. Say roots are m1 comma m2. Now, if the roots are m1 comma m2, then I can write as d plus m1 into d plus m2 into y is equals to x of t, right? Until this point, is it clear? So I have factorized it, and I'm assuming that there are two different roots because there are anyway two possibilities. One case roots are different, other case roots are equal. So I have considered the roots to be m1, m2, and then I have simplified from here to here. Is this point clear? Hello. Hello.
Yes, sir.
Okay. So now I'll make another assumption that this is my z of t. Say d plus m2 into y is equals to z of t. With that assumption, now I have two equations. One is d plus m2 into y is equals to z of t. And if I substitute that z of t back, I will have another equation. D plus m1 into z is equals to x of t. Understood? So what I mean trying to say is, if I substitute z of t here, I'll be getting d plus m1 into d plus m2 y is equals to x of t. So I have factorized into two terms so that I'll first solve for z and I'll put back z here and I'll solve for y. Is this step clear how from here I'm getting this step?
Yes, sir.
Okay.
That,
Now,
please,
okay.
please,
Okay. So I have this expression. So in this
please
expression,
repeat one.
okay. Okay. So I have this expression. So in this expression, I am considering this d plus m2 of y, which means my z of t is equals to dy by dt plus m2 into y. So I have assumed that this to be some z of t. If you substitute this as z of t, you will be left with this expression d plus m1 into z is equal to x of t. From the original equation, you will be getting this. Okay. But whatever I have assumed, that is what? Whatever I have assumed is d plus m2 of y is equals to z of t. So from here, you will be getting this expression. So now we have divided our second order linear differential equation into two first order linear differential equations. Why we have done that? Because we understood how to solve first order linear differential equation directly. So if an equation is given, we know how to immediately write the expression because we'll divide it into natural response as well as forced response. But there is one exception case and we have also studied that exception case. And for that exception case, we know how the solution will become at plus b into that expression. So now I can easily solve these two differential equations. So let us break this into two parts. Here part 1, here part 2. So part 1 is, first I will solve for z. So my z is d plus m1 of z is equals to x of t, which can also be written as dz by dt plus m1z is equals to x of t. Can you tell me the generalized solution for z of t if this kind of linear equation exists? We have
E to the
studied.
power minus m1t.
Yes, some constant a into e to the power minus m1t plus k0x plus k1x dash plus up to so on, right? Isn't it?
Yes,
Yes,
sir.
sir.
Yes. Now we'll get back to the other part, which is d plus m2 into y is equals to z of t, which means dy by dt plus m2y is equals to z of t. Now can you tell me what will be the expression, generalized expression? Say I'm considering this
Y
to
of
be
t equal to
a1.
y of t equal to a1.
Because here it is a1, I am considering a2 because they need not be same, so I'm considering a different value.
A1 into e to the power minus m2t
Hmm.
plus k0 into
K0 into
k0 into z
hmm.
plus k1 into z dot.
Dash. Yes. So it need not be again same variable. So I'll consider some different variable. K naught dash into z plus k1 dash into z dash plus up to so on, right? Do you agree with this?
Yes, sir.
Yes. So what is our actual question? Our actual question is solve for y of t, because here we have to solve for y of t. Okay, so we have divided it into two first order linear equations, linear differential equations. And then I got two expressions. One expression is y of t in terms of z, and then I got z of t in terms of x. So for getting y of t in terms of x of t, what I need to do, I have to substitute this z of t in y of t. Okay, so let me just substitute this. And see what I'll be getting. So my y of t, what it will be? A2 into e to the power minus m1t. So first term will be k naught dash into z is a1 e to the power minus m1t plus k naught x plus k1 x dash plus up to so on plus some k1 dash into z dash. So I have to consider the first differentiative or the first derivative. So it will be minus m1 a1 e to the power minus m1t plus k naught plus, so k naught x derivative will be x dash, right? So k naught x dash plus k1 x double dash plus up to so on. Did you agree? So this is my uh, so this part is my z and this part is my z dash. So I have substituted directly my z and z dash, and there are such infinite number of terms. Do you agree?
Yes, sir.
So now what I'll be doing is, say here there is some x coefficient, here also, here there is no x coefficient. And here there is x dash coefficient, here there is x dash coefficient. And here and here there is x double dash coefficient, here there is x double dash coefficient. So I'll segregate everything and write a generalized formula. So in general, I can write as y of t is equals to, so there are two coefficients here. This is e to the power minus m1t coefficient, e to the power minus m2t coefficient. So y of t can be in general written as some a1 into e to the power minus m1t plus some a2 into e to the power minus m2t. And kindly note that I have written here m1, it should be m2. This is m2. Okay, so these are exponential terms. Sorry. So along with the exponential terms, we'll have the generalized terms, x coefficient, x dash coefficient, x double dash coefficient. Maybe I'm not writing k naught dash into k naught x. I'm writing some another variable. Okay, say c naught into x plus c1 into x dash plus c2 into x double dash plus up to so on. Is this part clear? How we got? We have some generalized formula. We'll calculate the coefficients later. I'm just writing the generalized formula. Is this part clear, or should I need to explain it once more?
Yes, sir. Yes, sir.
Okay. I'll also again explain, or maybe some of you might have some confusion still. So they have given a second order differential equation. We need to solve this second order differential equation. So we have considered an operator d, which is d by dt. So d square is d square by dt square. And we have substituted it, and we have assumed that roots are different in one case, the other case roots are equal. So first we are proceeding with the first case, roots are different. If the roots are different, then we can factorize this as d plus m1 into d plus m2 of y equal to x of t. This I have assumed as z of t. Then I got two first order linear differential equations. So the previous main objective is to divide the second order differential equation into two first order differential equations. After these two differential equations, whatever we have learned previously, we have used the exactly same concept to get the expression of z of t as well as y of t. Then we have substituted this z of t here, and then we got a generalized y of t expression. So I hope until this point it is clear. So let me just quickly write what we obtained. So if the equation is d square y by dt square plus a into dy by dt plus by is equals to x of t, our equation is y of t is equals to, again it has some natural response and forced response. So natural response, now it has two terms because it is a second order. So it is a1 into e to the power minus m1t, say m1 m2 are the roots and they are not equal. Okay, plus a2 into e to the power minus m2t. So this completes our first natural response. Now the forced response will be some k naught or c naught or whatever. You can choose k naught into x plus k1 into x double dash plus up to x dash plus k2 into x double dash plus up to so on infinite. So this is here my natural response, and here this is my forced response. Okay, so in this way we can solve a second order differential equation when the roots are distinct or not equal. So this completes our first part where we have considered roots are different. So okay, so this is my strength. So this is roots are different. Okay, I think there is some issue with my pen. Let me just close it and open it. So you are clear with the second order differential equation, right?
Yes, sir.
Okay.
Yes, sir.
So we are here. We have completed the first part where roots are different. Now we'll go to the second part where roots are equal. So this will be somewhat interesting. Yeah. So the second part. So we are in the second part where roots are equal. So whatever we are doing, we are just uh, understanding the theory so that we need not do it again and again. So we are getting a or understanding the concept of how to write the y of t directly without solving. So after writing this expression, then we'll think about how to get the coefficients so that every time we need not divide it into single differential order equation because it is time consuming. So we are just understanding the theory. So how can we solve? And we got to know that second order differential equation can be easily solved by breaking down it into two first order linear differential equation. But there are two cases where roots are equal, roots are unequal. So we are addressing each of them one by one. So here my m1 is equals to m2 is equals to m. Okay. Now I'll quickly go back to this expression where d plus m1 d plus m2 y equal to x of t. Now here what will be happening? Here it will be d plus m d plus m is equals to x of t, right? Here there is a y. Do you agree?
Yes, sir.
Now
Yes,
again I'll do the
sir.
same thing, z of t. So now I'll get two equations. What are those two equations? Two first order equations, tell me.
Sir, dm into y is equal to zt
Hmm.
and dm into zt is equal to xt.
Yes. So these are my two things. First I'll solve. First I'll be solving for z. Then I'll be solving for x. So what will be the solution of this expression? What is y of t?
Y have to be a e to the power minus mt
Hmm.
plus k zt
Hmm. K naught z plus k1 z dash plus up to so on. Okay.
Okay, sir.
Yeah. Now, this is the trickiest part. So if you substitute that, we will get d plus m into zt is equals to x of t. So now what will be the expression for z of t? Some b into e to the power minus mt plus k naught dash x plus k1 dash x dash plus up to so on. Right? So this is
Yes.
dash plus k2 into z double dash. Now the issue is we can write this only when x of t is not that exceptional case. We have studied an exceptional case that if
E to the
my,
power minus
yes, if my this is e to the power minus at, where a is nothing but this a, then I will not get that form. Instead, I'll get some at plus b into e to the power minus at, right? So my y of t is not that. So here it is not true because this is an exceptional case, because this is an exceptional case because my x of t exceptional case, because x of t has this. No, sorry, this is my y of t into, no, I think I made a, okay, this is fine. So my z of t, first I think I have to solve for z of t and then come back to x of t. So this is the other way around. So first I have to solve for z of t and then I have to solve for x of t. So just, so I cannot write this because this is an exceptional case, because my z of t has e to the power minus mt, because z of t contains e to the power minus mt, right? Do you agree?
Yes, sir.
Yes. So now in such
sir.
scenario, what will be my generalized solution? So my again generalized solution has a natural response. Okay, Neeraj has raised his hand. If he has any query, you may
Sir,
ask.
for the exceptional case, sir, the
Mhm.
forcing function should only be an exponential function. But here, zt is, has one part exponential and the rest of the part
Are different.
other.
Yes, yes, you are right. You are absolutely right. You can actually break this z of t into z1 of t as well as z2 of t. So this is z1 of t and this is z2 of t. Now I can apply superposition because this is a linear system. So my y of t will have two components. One is because of z1t and the other one is because of z2t. So if I consider the y of t because of z1t, then what will be my expression? It will be at plus b, or say I'll use some different names, else it will be confusing. It will be a1t plus b1 into e to the power minus m1t, right? Or mt, because this is because of z1. Do you agree? Because I have separated z of t into two parts. One is z1t, one is z2t. Now I have realized that if my z of t is e to the power minus mt term, then my y of t will be at plus b into e to the power minus mt. Right? Do you agree?
Okay, sir.
Okay. No, if you have any query, you can ask. I will explain again. So, as you said previously, here we are having only exponential term, but in this case, we are having additional terms also. So, in such scenario, what I'm doing is I'm applying superposition theorem, where I'll say that y of t consists of two parts. One is because of z1t, the other one is because of z2t. So, if my z of t is b into e to the power minus mt, from this I can directly write y of t is at plus b1 into e to the power minus mt, right? Hello.
Yes, sir.
Yes. So now my other part is coming because of z2t. So if z2t is like a normal function, then I can follow whatever I have written here. So my like z2t is some expression, then my y of t will be a2 into e to the power minus t plus these expressions, right? So my other part will be some a2 into e to the power minus mt plus k naught x plus k1 x dash plus k2 x double dash plus up to so on, right? Do you
Okay,
agree?
sir.
So I have considered broken down the z of t into two parts, and I have seen the output y of t because of z1 and because of z2. And since there is a plus sign here, we will also be getting plus sign. I have just applied superposition. So response of y because of z1 plus response of y because of z2. Now you can see here b1 e to the power minus mt, here a2 e to the power minus mt. We can club both of them and we can name it as a difference coefficient. So my y of t is again having two responses. One is at, or I'll use a different capital At plus b into e to the power minus mt plus the other part k naught x plus k1 x dash plus k2 x double dash plus up to so on. So this is my final y of t. Is anyone having any doubt until this point?
Sir, we have clubbed both the exponential terms, sir.
Yes, yes, because it is some b1 plus a2. Why to write two terms? I have just named it some coefficient capital B, so that we just want to get the coefficient of e to the power minus mt, right? We need not calculate what is b1, what is a2. I just want to know b. So like a generalized format. So now I have to directly calculate for a, b, k naught, k1, k2, etc., etc.
Okay, sir.
So
Okay,
let
sir.
me just quickly explain this part again. If the roots are equal, then this is the equation that we'll be getting, which we are getting from this equation. After getting this, again, I have assumed z of t as well as x of t. First, I'll solve for z of t. Then I got this expression. Then in the case of solving y of t, we cannot directly write in the way that we have written previously, because there is an exception case which we have studied earlier. So in that exception case, we have got that solution will be at plus b into e to the power minus 80. So here z of t has two things. One is say I'm considering z1, the rest of the part I'm considering z2. The exception is only for z1. So for z1, I have written the solution using superposition. And now for Z2, it will be like a generalized format, which we have done in the distinct solution case. So after getting this, I have added them because it's a superposition theorem. So y of t will have summation of two outputs, one because of only Z1t and the other one because of only Z2t. So after getting this, I have generalized this solution. So if we want to again write the equations or the solution, d square y by dt square plus ay plus b. So this will be a dy by dt plus by is equals to x of t. Now we got two scenarios. One is the solution m1 is equal to m2, and the other one is m1 not equal to m2. So in the first case, it is very simple. It's a generalized. So it will be a1 into e to the power minus m1t plus a2 into e to the power minus m2t plus k naught x plus k1 x dash plus up to so on. Whereas in the second case, we'll get a1t plus a2 into e to the power minus mt or m1, because m1 is equals to m2 is equal to m plus k naught x plus k1 x dash plus up to square. So this is for the second one. Is this fine? how we are writing a generalized expression for second order differential equation.
Yes, sir.
Okay. Now let us go back to nth order. So now I am considering an nth order differential equation. So the nth order differential equation will be something like this: d to the power y n by d to the power n plus a0 d to the power n minus 1 y by dt n minus 1 plus a1 dt d to the power n minus 2 y by dt n minus 2 plus up to so on plus a n minus 1 y is equals to x of t. So this is the nth order differential equation. So now you tell me how to write the expression. Say we are again assuming case 1. All our all roots are different or all roots are distinct. So now what will be the y of t? And say the roots are m1, I will use a different color. The roots are m1, m2 up to so on mn. So if the roots we are getting from this, if you use the operator, you will get these roots. Say I have given the roots. Now what will be the expression for y of t? Anyone? Using this expression, something similar to like this. Hello, are you following? Hello.
Mhm. Yes, sir.
Okay. Can anyone tell me what will be the expression for y of t? If the roots are distinct and the roots are m1, m2, mn. Maybe you are wrong, but just give it a try.
Sir, a e to the power minus mt
Hmm. And
plus a2 e to the power minus m2t
I'm using a1 dash a2 dash because I have used it here. Plus up to so on.
plus an e to the power minus mnt
Plus
plus k naught xt
yes. Plus
plus k1
the
x dash t.
yes. So these are when the roots are distinct. Now I will consider another case. Say m1 is equals to m2 is equals to m, but rest of the roots are distinct. Okay. So now what will be y of t? So it is something similar to this. If both are equal, only this part will not be identical. Instead, it will be combined, and the rest of the parts are same. So, any guesses what it could be?
At plus b
Hmm.
multiplied by e to the power minus m1t
Hmm.
plus a2
Okay, just a minute. Okay. So here actually the roots are minus m1 minus m2 because it is d plus m1 d plus m2. So yeah. the roots are actually minus m1 minus m2 minus m1. So that's why we are getting minus m1t. Okay, fine. E to the power minus mt.
minus m1t
Hmm.
plus a1 e to
Hmm.
the power minus m3t
3t. So I'll use 3 so that it will be easy. Plus up to some a n dash e to the power minus m n t
mnt
plus k naught x plus k1 x double dash or x dash plus k2 x double dash plus up to so on. So in this way we can do. But before uh, concluding this part, I'll give another one last tricky case. Say m1 is equals to m2 is equals to m, and m3 is equals to m4 is equals to m5 is equals to say m dash. From other roots are distinct. Now in this case, what will happen? Anyone? Actually, roots are something like d plus m1, d plus m2. Okay. So for this case, what will be any idea? So like you can consider this to be individual case, this to be individual case, and then we can write the solution. Any ideas or any guesses?
no sir.
So we can treat them individually. So forget about this part first. First we'll consider this part. So for this part, what will be the expression? AT plus B, similar to case 2, right? So I'll consider A1, B1 into e to the power minus mt, right? So now here there are three roots. So if there is one root, we'll get b into e to the power minus mt. If there are two roots, we'll get a1t plus b1 into e to the power minus mt. So if there are three roots, we'll get something like this: a1t or a2 t square plus b2t plus c2 into e to the power minus m dash t. Now from the sixth root, it is same. Some a6 dash into e to the power minus m60 plus up to so on a to the power n dash e to the power minus m nt plus the rest of the part is similar k1 x dash plus k2 x double dash plus up to so on. So just to be clear, so this part is responsible for this part and this part is responsible for this part, and other roots are distinct. So if I use distinct other colors, so other parts are responsible for this. So these are all natural response again. So all these three, so whatever exponential terms are there, they are because of natural response. And the remaining part, this part, this is due to the forced response. So is this clear until this point?
Right, sir.
Okay. If anyone has any doubts, because I can only see one student answering all my questions. If others are facing any issue, you may tell so that we can discuss again.
Mhm.
No, no doubts. Okay. Maybe if you are facing any issue, I'm not saying, I'll just try to explain one last time. So for any nth order differential equation, first we'll get the equation in terms of d operator and say the roots are minus m1, minus m2, minus mn. One thing you need to be very clear: if the root is minus m1, then exponential will be minus m1. If the root is some m1, then exponential will be m2. So roots are minus m1, minus m2, minus mn, and I'm considering all the roots are distinct, which means m1, m2, mn are distinct. Then in that case, we'll have n exponential terms, which are the natural response, and the other terms are forced response. Simple. If two are equal, then instead of these two first terms, we'll get at plus b into e to the power minus mt, and remaining terms are same. And the last terms will be forced response. If we have some exceptional case like this, where two roots are equal and they are one value, other three roots are equal and they are some different value, and the rest of the roots are distinct. First, for these two roots, we'll directly write at plus b. If the roots increase, this expression will increase. So if three roots are equal, we'll have quadratic. If x roots are equal, we'll get x minus 1th order polynomial. So I have considered some different coefficients into e to the power minus m dash t, because my roots are minus m1, minus m2, etc. And the other roots are distinct. So from m6 to mn, it will be the same. And the other part is the forced response. So in this way, first, for any given differential equation, first I'll write the generalized solution. And then from there, I'll solve one by one, what is k0, what is k1, what is k2, what is a1, a2, etc., etc. So is this part clear until this point? Okay, we have a question. And there is less than a minute. If this meeting can kindly join, then we can discuss. So yeah, one very good question one student has asked, Naveen sir, why only natural response will changes and always not forced response? Because if we see from here, in this case, our natural response contains e to the power minus mt, and because of that, this part is changing, and my forced response is not contributing to my exceptional case, and so it remains the same. So that's why only my rational response is varying. Or I can say this exceptional case only comes when there is this e to the power minus this term. So, and it is only coming from the natural response terms, because those contains exponential and others are just derivative of x, x dash, x double dash, etc. So for that reason, so this term is coming only because of the natural response of this first order equation. And that's why only because of the natural response it is coming, and it will only affect the natural response, because we have seen that solution will be like this, and other forced response is like not changed. So that's why because of that reason only natural response is affected, because exponential terms are coming in the natural response only. Okay. So I hope that part is clear, Naveen. You, am I able to convince you, Naveen or Neeraj, whoever has asked? Okay. If you have any query, you can ask. So let me just summarize from the beginning. In the beginning, we have discussed about first order. So from the classical way, we have solved it and we got natural response as well as forced input. And then we have generalized that it will be natural response will be e to the power minus at, and this will be the coefficients with the derivatives of x of t. And then we have solved for one problem and with the boundary condition. And then we have solved for the variables, and then we got the answer. In the case of first order, there is an exceptional case when the input is e to the power minus at. So when I say e to the power minus at, it means this minus a, and also the solution, the root of this is minus a. So when these two are matching, then only that exceptional case will be there. If the RHS side, if it is e to the power a and it is not matching with the root on the LHS, then there will not be any issue. It will only happen when the roots on the LHS side is matching with this e to the power minus at. Okay, so in that exceptional case, we have seen what solution we are getting, and we have saved or remembered this result also, which we have used in the higher order differential equation. And then we have quickly solved one problem. Then we went to second order differential equation, which we have divided into two linear differential equations. So first, roots are different. It is pretty much straightforward. These two are because of the natural response, and these are because of the forced response. If the roots are equal, then it falls in the exceptional case. So we'll get at plus beta n to the power minus mt, and the other part will become exponential, not exponential, forced response. So using this result, we have again understood the theory behind nth order differential equation. If all are distinct, we'll have n exponential terms and the rest of the forced response term. If two are equal, then these two will be combined as AT plus B. If three are equal, those three will be combined as this. As three roots are equal, it will be quadratic. So if n number of roots are equal, we'll get n minus 1th order expression into e to the power minus that root into t, and remaining will be same. So yeah, now we'll get back to this say exceptional case. And we'll see, because I have told that if only these two are equal, then only it is exceptional case. If I don't have that exceptional case, but I have an exponential term. So what if I have exponential excitation? Say my expression is dy by dt plus ay is equals to some k into e to the power bt. Now one thing you have to see is this root is minus a, and here we have b, and say a is not equal to minus, or minus a is not equal to b. So now this is not an exception case. Exception case will happen only when b is equal to minus a. So the root on the LHS side is matching with that. So in this case, there is no exceptional case. And how we'll proceed? So yeah, first we'll again solve like y of t is y natural response plus y forced response, right? Okay. So natural response will be what? So this is no exception case. So some what term? Natural response. Hello. So natural response in the sense, my input I'll put 0, RHS will be 0. So the expression will be dy by dt plus ay equal to 0. So what will be the solution of that?
Identical to
Uh, Similar to whatever we have learned in the first slide. This one.
a
Yes.
into e to the power minus 80.
Yes. So it will be some different a, capital A coefficient into e to the power minus 80. Now forced response will be what? Some k naught into x plus k1 into x dash plus k2 into x double dash plus up to so on, right? Do you agree?
Yes, sir.
But if it is an exponential term, we'll get k naught into e to the power k naught k into e to the power bt plus k1 k b into e to the power bt plus up to so on, because e to the power bt is inevitable. It will always be there, right? Do you agree? Yes. So instead of writing all these terms, I can simply write some constant c into e to the power bt, right? So now what happens to my y of t? My y of t has become a into e to the power minus at plus another constant, say b into e to the power bt. So now this becomes the so because if it is exponential, the derivative terms will also be exponential. So instead of writing all those things, an infinite number of constants, I have denoted it as a into e to the power minus at plus some constant b into e to the power bt. So if you consider this, this is the natural response. And this is the forced response. But we have studied that forced response it itself will satisfy the equation. So my y f of n or y f of t is b into e to the power bt, and my differential equation is y dash, sorry, y dash plus ay is equals to k into e to the power bt, right? So this should satisfy. Okay, then we'll substitute and see what happens. If you substitute it in this expression, what we'll be getting is b into small b e to the power bt plus a into b into e to the power bt is equals to k into e to the power bt. So this will get cancelled. And what we are doing it for? We are doing for b. So my capital B is nothing but k by a plus b. So is this last part clear? So I have given a exponential excitation. Instead of normal function polynomial x of t, I have given an exponential excitation, and this b is not equal to minus a. If it happens in that way, then it will become that exceptional case, and my output will be some capital AT plus B into e to the power minus AT. But here it is some differential, some different exponential term. So again, I have followed our way of approach where it has natural response as well as forced response. Natural response is nothing but obtained from this roots of the LHS side. And I have realized that for the forced response, it will have infinite number of terms because e to the power bt can never become 0. So all these coefficients I have represented by b into e to the power bt, and this is my final y of t. But I know that for the forced response, if I substitute this term in this expression, it should satisfy, because else how can it be a solution, right? So it should satisfy. After substituting that, I got the value of b. So in that way, I will get the coefficient of b. But how will I get the value of a? They need to give some boundary condition to solve for a. So if there is any boundary condition, then using that, I'll get a. So is this part clear, or am I going too fast? Or if you have any queries, you can ask. Understanding?
Yes, sir.
Okay. So we have studied the exponential excitation. Now what happens with the sinusoidal excitation? Sinusoid excitation. Sinusoid excitation is also similar to exponential excitation. Why? Because you know this e to the power j omega t is cos omega t plus j sin omega t, right?
Okay.
And e to the power minus j omega t is cos omega t minus j sin omega t. So from these two terms, I can write cos omega t is nothing but half into e to the power j omega t plus e to the power minus j omega t, and my sin omega t is equals to 1 by 2j into e to the power j omega t minus e to the power minus j omega t. So now I have converted my sine or cosine term into exponential term. And we have already discussed for exponential term what will happen. So in this case, say if it is input is e to the power j omega t plus e to the power minus j omega t, here we will get a into e to the power minus at plus b1 into e to the power j omega t plus c1 into e to the power minus j omega t. And then you back substitute the forced response into this given equation to find that b1, b2. Similarly for sine. Understood. So sinusoid is nothing but exponential because we know the relation between cos theta and e to the power j theta. So we can convert that into sinusoid and sorry exponential, and then we can solve for the coefficients. I hope it is clear.
Okay.
Okay, then maybe I have gone too fast, and if you face any difficulty, you can ask me now because we are going to problem solving session. So at any part, if you have any query, you can ask me. Don't think that you'll let it go through the lectures because I'm here. You can ask me, then we can spend more time on understanding. Okay, if you face any difficulty, you may ask at any moment, even if we are solving problems and you are facing difficulty. Let us consider this assignment. So maybe I'll not solve them fully, but I'll ask you how to solve. Say, I'll just tell you the procedure because mathematical solving will take time. So yeah, let us consider this question. So yeah, how to solve this question? So this is first order uh, differential equation. So what will be the general solution? Anyone?
So it is equal to e to the power minus 4t
Some constant, of course, yeah. Plus,
plus kt plus k1.
yes. So this is the natural response, and this is the forced response. So first we have to write the generalized expression for y of t. After writing that, then we will see what are the coefficients. So first we'll find the forced response coefficient. So how to find the forced response coefficients? How to find K1, K2? Or
Sir,
sorry,
by
K not
putting
K1?
them in the equation, sir.
Yes. So you substitute this expression. So can you quickly calculate? All of you, can you take your pen and paper and solve quickly? And I see only one member answering all my questions and other are silent. So I'll not know whether you are able to understand. See, this is not a lecture where I'll be teaching and you'll just listen because this is more of an interactive. That's why NPTEL people have started this. So instead of writing your queries under the chat box, which may or may not be answered quickly, we can ask during this session. So we can explain you in live so that you'll get better understanding of the concepts. Anyway, so uh, have you substituted what I'll be getting?
K naught is equal to 1 by 4.
So I'll get K naught plus 4 into K naught T plus K1 is equals to T. So I'll have two equations, 4 K naught is equals to 1 and K naught plus 4 K1 is equals to 0. So what are the values that you are getting?
Sir, k naught 1 by 4, k1 minus 1 by 8.
Okay. 8 or 16?
Sir, 16,
Yes,
16,
yes.
sorry, sir.
So yeah, now I'll substitute this here. Now my y of t will become a into e to the power minus 40 plus t by 4 minus 1 by 16. And they have given y of 0. Y of 0, I think they have given 3 or something or 1, 2. So y of 0 is 2. So now can you calculate a? All of you, I'm only seeing one student answering. It should not be like that. Everyone should be equally participating. Solve with us. So we can cross check who is right or who is wrong. Someone has, okay, yes, sir. Okay. Anyone who has solved A, just substitute T equals to 0 and then solve for A. Anyone? You should not take this much time. Just T equals to 0. So LHS will be 2, RHS will be A minus 1 by 16. So what will be the value of A? 2 plus 1 by 16. And what is the value of A?
33 by 16.
Yes. A value is 33 by 16. So now my y of t as a whole will be 33/16 into e to the power minus 40 plus t by 4 minus 1/16. So I hope all of you are doing this. And so which one is the answer in this case?
So last one, D.
Yes, D is the option. Okay, this is one problem where it is just first order. But if you consider this problem, yes, this is a bit complicated because it is a second order. I'll not fully solve, but I'll tell you how to proceed with this problem. So you can solve later because we are running out of time and I'm planning to solve more variety of problems, so you'll understand how to solve different variety of problems. But as it involves most of the problem is about math, I'll not get into all the calculations. I'll just let you know how to solve such problems. So problem 2, we have a second order equation. So what is the equation? The equation is y double dash plus 5y plus 6y is equals to 1 plus 2t plus 3t square. First, I'll calculate what are the roots. Can you tell me what are the roots? T square plus 5d plus 6 equals to 0. So what are my roots? What are d?
So -3 -2.
Minus 2 minus 3. Yes. Now what is the generalized solution? Can anyone say? A into something. Hello. Anyone? The roots are minus 2 minus 3 and this is my x of t. So generalized solution in terms of a m1 m2 and x of t.
So a1 e to the power -3t
Okay.
plus a2 e to the power -2t
Okay.
plus k naught into this whole expression xt
Yes. Plus k1 into
plus k1 into the whole
x dash.
x dot t.
Okay, so it will be 2 plus 60, right?
Yes,
And
yes,
k2 into 6, other terms are 0. So this is my
yes.
generalized expression. So now what we need to do is first we will find the forced response. So in any case, first we will get the forced response because we'll substitute back this, we'll substitute this back in the given equation and solve for k0, k1, k2. So whatever expression you have, this expression, you substitute in this. So you'll get y double dash plus 5 into y dash plus 6y is equals to 1 plus 2t plus 3t square. And then you solve. I will not solve because this is a very lengthy problem. So I'll just write. So this is y n of t and this is y f of t. So the method is like this. Substitute y of t in given differential equation and solve for k0, k1, k2, k0, k1, k2. So once you obtain the k0, k1, k2, now you have to find a1, a2. How do I find a1, a2? So they have given this boundary condition. They have given y of 0 is equals to 1 and dy by dt of 0 is equals to 2. So y of 0 is nothing but you substitute 0 here, it will be a1 plus a2 plus k0 plus 2k1 plus 6k2. That is y of 0. So we have y of 0 is what? 1 and other one is 2. So y of 0 is 1 and y dash of 0. So first you have to calculate y dash of t and then substitute 0. Not substitute 0 and then differentiate because then it will not give a correct value, it will give 0. This is 2. And now you have two equations and two unknowns. So what are the two unknowns? A1 and A2. Solve for A1 comma A2. So first, what we have decided here, we have got the generalized equation from the given expression, and from the expression we have 5 unknowns. So we have to find 5 unknowns. So first we'll be solving the forced response where K0, K1, K2 are unknowns. We'll substitute this in the given expression, and then we'll get uh, LHS side and RHS side. So you'll get three equations because the coefficient of t square, t, and t to the power 0. So you have three coefficients on the LHS side, three coefficients on the RHS side. Solve for K0, K1, K2, three equations, three unknown. After getting K0, K1, K2, using this boundary condition, you will get two equations, then solve for A1, A2, then you'll get the overall expression. So y of t, I want you to do later. So kindly note that the answer is C. So you will be getting this. So please do this after this session, because this video will be available online. You can come here and solve it. So you check how this procedure goes. So it will be useful for your exam or assignment, anything. So, but I recommend everyone to do this problem because it is a very lengthy problem. Also, it requires a lot of understanding. So you follow these steps and then you'll get. If you face any difficulty, you mention in the comment section. I'll address all the queries. But do not forget to solve this problem. I'm not solving because this is very lengthy and I cannot cover multiple number of problems. So I'm just quickly covering how to solve different kinds of things. So yeah, this is sine omega t. We'll solve this problem also. Okay, maybe we'll solve some simple problem, then you'll understand how to solve. This is also okay, seventh problem. And so mainly you'll be getting these type of equations where previously in assignment 1 and 2 you have solved for what? You have solved for steady state. So here you are not solving for steady state, you are solving the differential equation. So you will get currents or voltages as a function of time. So I will take up this sign question, which again needs some level of understanding of the concept. I'll let you know how to solve this. So let me consider this problem 3. Okay. So any idea how to start with this problem? Anyone? Okay, first of all, tell me the expression. At least the different. First, we need to. Here there is no differential equation. We need to frame the differential equation and then we need to solve it. Okay. What is the differential equation? In terms of voltages, can you say input voltage equal to summation of resistor voltage as well as inductor voltage?
Mhm.
Yes, so 10 sine omega t is equal to 4 it
So sine omega
plus
is 300 and substituting is equals to 4 it
4
plus
it plus sir 1 by 100
into di by
di
dt.
by
So I'm denoting I as y. So it would be easy to understand. Now what we'll have? We'll have dy by dt plus 400y is equals to 1000 sine 300 t. Do you agree? Yes or no?
yes, yes, sir.
Yes.
Mm.
Okay. Now again it has two parts. One is the natural solution, one is the natural response, and the other one is the forced response. Forget about the forced response for the time being. First we'll do natural response. So what is the natural response? y of t is, so natural response means input you keep it 0, and dy by dt plus 400y is equals to 0. So what will be y n of t?
Sir, a to the power minus 400t.
Yes, a into e to the power minus 400t. We'll solve for a later, but first we'll write the overall solution and then we'll come back to how to solve for the coefficients. So this is natural response, very good. Now we'll go back to forced response. So we have discussed for a function like sine or cosine, we can follow the exponential uh, excitation procedure. Only we need to convert this into e to the power j omega t. So 1000 sine 300t can be written as what? 500 by j into e to the power j 300t minus e to the power minus j 300t, right?
Okay, sir.
Yes, because I can write in e to the power j omega t plus e to the power minus j omega t. If you are having some confusion, we'll
Using
get back to
Euler's
it.
formula.
Yes, so we have this e to the power j omega t, e to the power minus j omega t. By doing addition and subtraction, you will get cos omega t, sin omega t. So sin omega t is 1 by 2j. So that's why I have this 1 by 2j term. So 1 by 2j means 1000 by 2j, which is 500 by j, and I'm leaving it like that. So now I have told you that if the exponential term is not the solution on the LHS side, then forced response, we can directly take a coefficient of uh, the exponential term. So yf of t, I'll take a into e to the power j 300t plus b into e to the power minus j 300t. Is this clear?
Hmm.
Because my input is exponential term. So I have considered there are two exponential term. Again, you can consider it as a superposition theorem. So this is responsible. E to the power j3t is responsible for this. So if I use different color, maybe pink. So this is responsible for this. And if I use black color, this is responsible for this. Okay. Now I got forced response equation. So for any question, first we'll solve for the coefficients of forced response. So forced response, how will I solve? I will solve by substituting this expression in the given differential equation. Okay. So now can you tell me if I substitute that, what I will be getting? Tell me quickly. dy by dt will be what? Three hundred j a e to the power j 300t minus 300 j b e to the power minus j 300t plus 400y. So 400 a e to the power j 300t plus b 400b e to the power minus j 300t. I know that 1 by j is 1 by j is minus j. So substitute this here. So now my RHS will be what? My RHS will be minus 500j e to the power j 300t plus 500j e to the power minus j 300t. So is this fine? I have substituted here and I got this equation. So now I have again two equations to announce. How? The coefficient of e to the power j 300t and the coefficient of e to the power minus j 300t. So if I write the equation, okay, there we have one question. Yes, sorry, Ravin, I have not seen your message. Yes, you are right. The expression. Now I'll have two equations to announce. So what is my equation one? My equation one is a into 400 plus 300j is equals to minus 500j. So now my a will be what? Minus 5j by 3j plus 4. And my b will be what? b into 400 minus 300j is equals to 500j. That implies my b is equals to 5j by minus 3j plus 4. Fine. How I am getting this equation? So for blue, this part, as well as this part. I'm comparing those three. And for the red, I'm comparing this part, and this part. So I have added it, just compared them. Now if you solve, as we are running out of time, I will directly write what you will be getting. So we'll be getting something like minus 1 by 5 into 3 plus j4. And this one will be 1 by 5 into minus 3 plus j4. I'm writing this because it will take some time to solve and we are running out of time. Okay, now I got value A, I got value B. Now we'll get the forced response, right? Forced response is what? Yf of t is A into this one plus B into that one. So now what I'll be getting? I'll be getting minus 3 by 5. Right. So this minus 3 by 5 minus 3 by 5 into e to the power j 300t plus e to the power minus j 300t plus. So first I have considered 3, 3. So here minus 3, here minus 3. Now here it is minus 4j, here it is plus 4j. So I will take out minus 4j common, minus 4j by 5. It will be e to the power j 300t minus e to the power minus j 300t. Right. Is this okay? I have substituted this A and B in this equation so that I'll get my forced response, and this is my overall expression. Is that okay? Okay. So now if you calculate this, you will get yf of t is equals to, this will be 2 times cos 300t. So 2 times means minus 6 by 5 cos 300t, or maybe I'll write. So this will be 2 cos 300t, and this is 2j sin 300t. And 2j into minus 4j is 8 because j square is minus 1. So we will get plus 8 by 5 into sin 300t. Okay, so this is my yf of t. Okay, so yf of t is obtained. I'll again write the overall solution. So my overall solution is a into e to the power minus 400t plus this solution. So my y of t is a into e to the power minus 400t plus 8 by 5 sin 300t minus 6 by 5 cos 300t. How do I calculate A? There should be some boundary condition. I'll go back and see. The boundary condition says that find the expression I of t for t greater than 0, the switch is closed at t equals to 0. So before t equals to 0, the system is open. So
I
what is
is
the
0.
value of current? Current is 0. Here my current is y, right? So I will have this condition y of 0 is equals to 0. Right. So if I substitute y of 0 equals to 0, what will be the value of A? Anyone? Quickly. Sine will be 0, cos will be 1, e to the power will be 1. A is what? Hello. isn't it? A equals to 6 by 5, right? Hello.
Okay.
Yes. Now what will be my final y of t? My final y of t is 6 by 5 into e to the power minus 400t plus 8 by 5 sine 300t minus 6 by 5 cos 300t. This is my final answer. We'll see 6 by 5 e to the power minus 400t plus 8 by 5. So 6 by 5 e to the power minus 400t plus 8 by 5 sine or cos sine 300t. So this is my answer. Correct answer is A. But in this question, there is a catch. I think it has two answers. So it is A as well as C. So you check by simplifying these two. So if you add these two, you will be getting 2 sine that term. So you check by simplifying this. Simplify this. Like sin A, sin B or cos A, cos B. You check that and simplify. There is less than a minute. And after that, we'll join back again and I'll summarize what we have discussed quickly. If you have any queries, you can ask. Maybe I went too fast at the end because we have very less time. And as I'll be uploading this, if you still face any issues, you go through the lecture. If you have any queries, you can ask in the comment section. I'll address them. If this, can you see my screen? Hello.
Yes, sir.
Okay. So in the last problem, the input excitation is sine. So we have realized that for sine, we can write in two terms of exponential, and we have realized that if it is exponential and if it is not having the coefficient of the root on the LHS side, then we can write the forced response as this, and natural response we already know it is quite simple. For calculating this AB, we have back substituted this in the given expression, and we have solved for AB. After getting AB, I have simplified the forced response. I got this response. Then my overall y of t is this. Considering y of 0 equals to 0, I got A, and this is my expression. And in this question, there are multiple answers, so both A and C are true. You just have to combine this and write in sine 300t plus some theta, where theta is given by minus tan inverse 3 by 4. You check that calculation, it is simple. So let me just again summarize what we have discussed. So today uh, we have planned to discuss the solution to linear differential equation. First, we started with the first order differential equation with the classical approach, and then we got a generalized expression. From there, we have understood the theory, how to extend this to other set of linear differential equations, and we have considered one example, and we have solved that example. And then we have discussed how to calculate the coefficients. So there will be one boundary condition, and the other one is this natural the forced response will satisfy the given differential equation. So from there you will get the forced response coefficients. Using this boundary condition, you will get the natural response coefficient. And then we have discussed there is an exception case when this root on the LHS side is matching with this. In that case, we'll get something like 80 plus b into e to the power minus 80. We have taken a quick example and we have seen how to solve that. Then we went to second order differential equation, which can be solved by factorizing it and converting it into two first order linear differential equation term problems. So there will be two cases. One, the roots are different, the other roots are equal. So in the roots are different, we have solved two differential linear first order equations. And then we have substituted back and we got a generalized solution. This one is natural response, other is the forced response. If the roots are equal, then it will fall into that exception case, because whatever root on the LHS side, it is matching with this exponential term. So then either you can think of a superposition theorem where there are two different excitations. So the output will be summation of output due to excitation 1 plus output due to the some excitation 2. So for this exception case, we know this is the solution. And for this, we know this is the solution. And we can combine these two terms and we can write as a generalized solution. So for a given second order equation, if the roots are unequal, this is the generalized solution. If the roots are equal, this is the generalized solution. Then we went on to the nth order differential equation where the roots are n number of roots. So if all the roots are distinct, then we'll have an exponential terms and rest of the derivative terms of x. If we have something equal, say two roots, then we'll have this expression and remaining are square. If we have multiple such cases, then if n number of roots are equal, then you have to write a polynomial for n minus 1th order uh, of t time polynomial. So similarly, individually we'll write and then we'll do summation and followed by the other roots and then followed by the forced response. These are some nth order differential equation with normal polynomial excitation. Then we went into the exponential excitation where this is not matching with this. Then we have realized that forced response will be coefficient into this exponential term. How will we get that coefficient? By substituting back into the given differential equation. We'll get that coefficient, and how to solve for the coefficient of the natural response using the boundary condition, we'll get A. So in any question, they will give that boundary condition. So you'll have enough number of equations to solve for all the unknowns. And if it is a sinusoid excitation, then we will convert that sine or cosine into exponential and it will fall into this problem. So we have started with an initial problem, first order equation. We have used our theory that we have learned today and we have solved for coefficients, first forced response followed by the natural response coefficient. And then we have considered second order, which will be somewhat lengthy and somewhat complicated. And due to lack of time, I have not solved this, but I have discussed how to solve this. So you please try after this session and match your answer with this option C. It should match because I have already done it and it is matching. So in this equation, again, we have got the generalized equation. One is the natural response, other one is the forced response. For the forced response coefficients, substitute this back in this equation. We'll get three equations, three unknowns. The three equations are coming from the coefficient of t square, coefficient of t, and the constant. So you'll have three equations on the three expressions on the LHS side, three expressions on the RHS side. By comparing them directly, you'll get three equations, three unknowns. Solve for k0, k1, k2. After solving k0, k1, k2, using these two boundary condition y of 0 equal to 1 and dy by dt of y 0 equals to 2, you will get another two equations, two unknowns in a1 and a2. Solve for a1 and a2, then your final expression will come something like this, followed by the sinusoid excitation, which we have discussed at then. If the input is sine, then we have written it as summation of two exponential terms. Then we have calculated the natural response. Forced response will be coefficients multiplied by that exponential terms followed by summation of those terms. Then we have substituted this back in this equation to get AB. After getting AB, we have simplified the forced response. Then for calculating the natural response coefficient, we have used the boundary case and then we got the response. But in some cases, you have to also check whether other expressions are matching. These two might seem different, but if you simplify these two, like sine A cos B minus cos A sin B, sine of A minus B, if you apply that, then you will be getting this type of expression. So you kindly check that after this session, but due to lack of time, I'm not showing all the detailed mathematical simplification. So if you have any query, you may ask, else we can wind up this session here. Any queries till this point? Whoever is left, are you able to understand all the concepts and how to solve the equations? Similarly, if there are
Yes.
any RLC circuit, first you write the differential equation in this, and then you solve the differential equation. First natural response, then forced response. One by one you can do, and yeah.
Sir, for calculating the force response in the last question, sir,
Mhm.
the the general form was a e to the power minus at plus b e to the power bt.
Yes.
Sir, sir, the a term is 400, sir. There is no e to the power 400 term, sir, here.
No, no. There are two terms. One is the natural response. Natural response is coming from this LHS side, which is giving a into e to the power minus 400t. And the forced response is coming from the RHS side. So RHS side we have j into 300t e to the power minus j into 300t. So I have considered two terms. One is a into e to the power j 300t. Other one is b into e to the power minus j 300t. After this, I have
Oh,
substituted here, and then I got two equations, two unknowns, and I have solved to get a and b.
sir, here the excitation has two partners, sir. E to the power minus j
Uh-huh.
300t,
Mm-hmm.
e to the power.
J 300t.
Yes, sir.
So this part is responsible for this term, and this part of black I use. So this part is responsible for this term. Since the coefficients are unknown, I have assumed plus. So thinking that A, B are positive, but you are free to uh, you can also write minus B also, but in that case your B might be different. Yeah. Is that clear?
Yes, sir, yes.
Yes. So if there are n number of exponential terms in the input, then we'll assume n coefficient multiplied by the n exponential terms followed by a summation. Then we'll solve for the n coefficients. If it is only one exponential, then it will be only one exponential multiplied by an unknown coefficient. Okay, then if you have no more queries, then we can end this session here. Kindly go through all the lecture notes, so that you will understand what type of uh, theory we use to solve all the differential equation and solve n number of problems. So then you can correlate your theory with how to solve a given problem. In majority of the problem, the differential equation will not be given. Instead, they'll give a circuit like RL, RC network. Then you have to write the KVL or KCL, and you have to first get the differential equation, and then you have to solve for the differential equation. So the steps are as follows. First, from the given circuit, get the differential equation. After getting the differential equation, first write the natural response. Then you write the forced response. Then you substitute the forced response in the given differential equation to get the unknowns in the forced response. Now you got the forced response fully with all known coefficients. Now using a boundary condition, solve for the natural response. So the steps are very straightforward, but it depends upon how you are calculating. So there is a lot of math involved in this, and you have to be correct in each and every step, else you will not get right answer. So we often tend to do more mistake in math, but the only way is to do more and more problems. So then we feel more and more confident, and the tendency to do or to commit a mistake will be reduced. So yeah, solve more and more number of problems, or you can give yourself a differential equation and solve for it, and back substitute it to check whether your answer is right or wrong. Also, you can get a number of problems online, previous year assignment or this year assignment you can solve. Okay, with that being said, I think we can end this session here.
Okay, sir. Good night.
Okay, thank you. Good night.